The neural fingerprint. How 5 psychedelics reshape the brain, a major international study has identified a shared neural fingerprint across 5 different psychedelic substances, suggesting that despite their different chemical origins, these drugs influence the brain in a remarkably similar way. By analyzing data from multiple sources, researchers have moved past studying these substances in isolation, uncovering a common pattern of brain activity that could revolutionize how we approach mental health treatments. A unified pattern of brain activity. Historically, research into psychedelics has been fragmented. Most studies focus on a single drug and a small group of participants, making it difficult to see the big picture. To overcome this, an international team of scientists pooled data from 11 different datasets, encompassing 519 brain scans from 267 participants across 5 countries. The study examined 5 distinct substances: psilocybin LSD, lysergic acid diethylamide, mescaline DMT, dimethyltryptamine, ayahuasca. Using fMRI scans, the researchers identified 2 primary shifts in how the brain functions under the influence of these drugs: increased cross-network communication. Distinct brain networks that usually operate independently began communicating more intensely with one another. Selective internal reductions. While communication between networks increased, certain connections within specific networks were selectively reduced. Flattening the brain's hierarchy, the study found that this boosted interconnectivity occurred in cortical networks responsible for high-level thought, as well as regions associated with sight and touch. This explains the vivid sensory experiences or hallucinations often reported by users. Furthermore, the changes extended to deeper, subcortical regions like the caudate, putamen, and cerebellum, which coordinate perception and action. Researchers describe this phenomenon as a flattening of the brain's normal hierarchy. Instead of specialized regions performing isolated tasks, the brain enters a state of heightened, globalized crosstalk. For the first time, we show there's a common denominator among drugs that we currently consider completely separate, says Danilo Bzdoc of McGill University. Why this matters for mental health: this discovery challenges previous scientific assumptions. Earlier studies often suggested that psychedelics caused a breakdown in brain connectivity. This new evidence suggests the opposite. The brain isn't breaking down, it is reorganizing. This distinction is critical for the development of medical therapies. If scientists can understand the exact biological mechanism behind this flattening, they may be able to engineer treatments that harness these changes to address major depression, substance use disorders, anxiety, and mood disorders. The similarity between psilocybin and LSD, noted in the study, further reinforces the link between chemical structure and subjective experience, providing a clearer roadmap for drug development. Challenges and the path forward. While this study is a breakthrough, it is not without limitations. The researchers had to work with messy data, as the original datasets used different dosages, timings, and administration methods. The next phase of research will require standardized testing protocols to minimize variables, larger, more diverse participant groups, clinical focus on how these neural patterns translate specifically into therapeutic benefits. As the scientific community moves away from the era of criminalization and toward controlled, safe research, the potential for a paradigm shift in psychiatry grows. As Bzdoc notes, psychedelic research may represent the most significant evolution in mental health treatment since the 1980s. Conclusion: by identifying a universal neural fingerprint, researchers have provided a foundational biological map for how psychedelics alter consciousness. This shift from viewing these drugs as disruptors to reorganizers of brain connectivity opens new doors for targeted, effective mental health interventions.